Hello students, welcome back. Today in this video we are going to discuss this chapter 7 about trigonometry. Now we have learned this one in general maths course of class 10. Okay, we know that trigonometry is always related with a right angle triangle. Okay, we are always discussing, that means we have trigonometric ratios. We know those are sine, cosine, tangent, cotangent, secant and cosecant, which we can, in short, we can say sin theta, cos theta, tan theta, cot theta, sec theta and cosec theta. This we have learned in our general maths course, okay, in this year. So we'll be dealing with always right angle triangle, and we know, we have heard about, we know sine. For sine it is always p by h, perpendicular by hypotenuse. Cos is b by h, okay, and then tan is p by b. Then sine, this cosec is 1 by sine, so it will be h by p, and this sec is 1 by cos, so it will be h by b. So we know these all things we know. Okay, if it is for the angle is named as theta, it will be theta. If it is psi, so it will be psi. Okay, now here you are given some, we in general maths we have got some standard angles like the 0 degree, then 30, then 60, 90, sorry 45, I missed the 45, 30, then 45, 60 and 90. These are the standard angles. We know the values of these standard angles. Okay, now we were restricted to only this quadrant, or probably we have learned till the second quadrant. Okay, mostly we have gotten for the first quadrant. So we know we have 4 quadrants. Okay, we have 4 quadrants. Okay, so this is the first, this is the second, this is the third, and this is the fourth quadrant. Okay, so we have 4 quadrants, and these are all 90 degrees. They are perpendicular to each other. Both the axes are perpendicular to each other. Okay, so we have 4 quadrants. Now here we'll be dealing about angles even greater than 90, greater than 180, greater than 270 and less than 360. That means we'll learn what will be the values of different trigonometric ratios for falling in different quadrants. Okay, so I will be always dealing with the ray will be taking always on the positive direction. That means what it makes with the positive direction of x axis. Okay, I will explain this in another video. Today here we'll be explaining, we'll be learning about different angles. Okay, and trigonometric ratios falling in different, that means the angles falling in different quadrants. We'll start from this minus theta, then 90 degree minus theta, then we have 90 degree plus theta, then we have 180 degree plus theta, likewise we'll have. Okay, and we have different sign conventions for those. Okay, so in another video we'll learn about the geometrical interpretation of this trigonometric ratios. At first here we'll learn about what will be the values. We'll learn about the values. Okay, what we'll write the corresponding values for different trigonometric ratios falling in different quadrants. Okay, so the sign conventions are given here. the sign convention here. You see, this is the sign convention. That means which quadrant. These are all different quadrants. Okay, 90 degree plus theta or minus theta, whatever. We have the sign convention. That means plus minus means where sign will be positive, sign will be negative. Okay, it will take plus or minus. So I'll give you an idea, a trick how to find out this all. Okay, so for this, but I'll show. Okay, now for this we have to remember one thing. Of course we have to remember so we have 4 quadrants. 1, this is 2, this is the 3rd quadrant, and this is the 4th quadrant. Yes, we have 4 quadrants. 1, 2, this is the 1st quadrant, this is the 2nd quadrant, this is the 3rd quadrant, and this is the 4th quadrant. Now you all have to remember that this one A, you have to remember this way, ASTC. It is easier to remember, ASTC. Now remember what does ASTC means. Here all the ratios, trigonometric ratios, are positive here. Okay, so all positive. That means sine, cos, tan, cosec. So when I say sine, cos, tan, that means their reciprocals will also follow the same convention. So I will say only for the sine, cos and tan. Here S means here only sine is positive. The 2nd quadrant only sine is positive. Obviously when we are considering sine, that means we are also considering its reciprocal, cosec. So I will not say about cosec now. You have to remember here it is 1st quadrant, it is all positive, 2nd quadrant sine positive, then here it's only tan is positive. That means tan along with cot, and then here cos positive. Okay, so you have to remember for the 1st quadrant all positive, 2nd quadrant only sine positive, 3rd quadrant tan positive, and 4th quadrant cos positive. That means this ASTC, you have to remember this ASTC, all positive, AS, then TC, all positive, sine positive, tan positive, and cos positive. Okay, now see, if you look at here, these are all 90 degrees. So when we are saying 90, so if you are taking, say this as theta, okay, obviously this is 90 degree minus theta, so that means it is an acute angle, so it will fall in this quadrant, 1st quadrant. Now when you say 90 degree plus theta, so 90 degree plus theta will fall in the 2nd quadrant, and even 180 degree minus theta also will fall in this 2nd quadrant. This one will be 3rd quadrant, will be 180 plus theta, and this is 270, so it will be 270 minus theta. This will be 360 minus theta, this will also be 270 plus theta, and sometimes we also say minus theta. Okay, so you have to remember this all. That which quadrant, on adding to the angle or subtracting from the angle, on which quadrant it will fall. Okay, so now how to find the sign convention? Now you have to remember whatever the angle is given, say when the angle, you have to see, you have to divide it by 90. Okay, you have to divide it by 90, and whatever it is, if it is say odd number, multiple, and then we have another remainder. Okay, then remember it changes, and we know the changes from sine to cos. The changes are, okay, we know the changes. It always changes. Sine changes to cos and cos changes to sine. Tan and cot, they are same if they are reciprocal also, and they are also same. Cosec and sec, they change to each other. For example like sine of 90 degree minus theta is always cos theta. So if you look at here, this 90 degree, this is, how we can write this one? It as 90 degree into 1. Now this 1 is odd. Now remember, when it is odd, it changes from sine to cos. Okay, now same way, now that is what, and it is positive. And then if you take this sine, say 90 plus theta, so you know it is, this is 90 into 1, that means this is odd multiple. So when it is odd, it will change to cos. This theta will be theta here, same angle. And then you see this 90 degree plus theta means 90 degree plus theta, this is 90 degree, so plus theta means obviously it will fall in this quadrant, so second quadrant. And by ASTC we know second quadrant sign is positive, so that means we have to see for this one. For 90, this sign will change or not? The sign change to cos, so due to odd multiple. And then we have to see on which quadrant. It is the second quadrant. Second quadrant sign is positive, so it is plus positive cos theta. So we don't write positive, we write it as cos theta. Similarly, say for cos 90 degree plus theta, 90 degree plus theta. Now what you have to see, 90 degree plus theta is always on the second quadrant. So second quadrant we know cos is negative, that one we'll discuss later on. Now at first we have to look at here, this 90 is odd multiple, 90 into 1 we can write. So as it is an odd multiple, this cos will change to sine. So odd multiple, cos changes to sine, and theta is theta, it will remain the same. Then we'll go for the sign convention. 90 degree plus theta means it is in the second quadrant. 90 degree plus theta second quadrant, and second quadrant we know this ASTC, so that means only sign is positive, but we are taking here cos, so sign is positive only, so it will be minus sin theta. So cos of 90 degree plus theta is minus sin theta. Now we'll come to the even ones. Now see, for example, sine of say 180 degree minus theta I am taking, okay, and then I am taking sine of 180 degree plus theta. For sine of 180 degree minus theta, we know 180 degree minus theta means it will fall on which quadrant? 180 degree minus theta is on the second quadrant, and 180 degree plus theta is in the third quadrant. Okay, now look at here, this 180 is 90 into 2, that means even multiple. Okay, even multiple of 90. So when it is even multiple of 90, the sign does not change, that means it remains the same, so it will remain sine theta. Okay, same. For the now we'll see the sign convention. Now it is on the second quadrant, and we know in the second quadrant Sine is positive, ASTC, so it will be positive sine theta. So we will not write plus. For the second part, again it is even multiple, so sine theta will remain sine theta. It's not a problem. Now we'll see it is on the third quadrant, and we know ASTC, AST and C, ASTC. So this T, third quadrant, on the third quadrant T is only positive, that means only 10 is positive. But here if you see, we have sine, so it falls on this quadrant, and sine is negative here, that means it is 10 is positive, means other ratios will be negative. So sine, it will become minus, that means it will be minus sine theta. Likewise, we can do any equation, we can find the value. Like say 10, we take tan of say 270 plus theta. So tan of 270 plus theta, and we have, say, we can take cot of 270 minus theta. Okay, now at first we have to see this 270. This 270 is, you know, 3 times, so odd multiple. So when it is odd, tan changes to cot. So for both, and then here cot will change to tan. So they will change. This tan theta will change to cot theta, and this cot will change to tan theta, because it is odd multiple. Now we'll see the sign convention. What will be the sign? Now this 270 plus theta means 270 plus theta, this one is 270. Remember, this is 0, this is 90, this is 180, this is 270. So 270 plus theta will be on the fourth quadrant, and fourth quadrant we know ASTC, only cos is positive, so that means only cos positive, that means this tan will be negative. And 270 minus theta means third quadrant, and third quadrant tan is positive, so tan positive means cot also positive, so it will be plus tan theta. So we will not write the plus, so it will be tan of 270 plus theta is minus cot theta, and cot of 270 minus theta, degree minus theta, is tan theta. This way we do. Okay, now another important part. Now if you are given more bigger angles, like we have tan of say 1845 degree. Now how can we write this one? For this, what we have to see, what is the multiple of 90. So we know 90 into 20 is 1800, and then we have another angle, it is 45 degree. So 1800 plus 45 is 1845. Now we'll write, now this 45 will remain 45, so we'll write 45 degree, angle remains same. And this is, you know, 90, it is even multiple of 90, so tan will not change, that means it will be tan 45 itself. So tan 45 degree, but we don't know in which quadrant it will fall. Now we'll see here on which quadrant to fall. Now see this, it is 0. Okay, this is 0, this is 1, this is 2, and this is 3, and this is again 4. Then this is 5, this is 6, this is 7, this is 8, 9, 10, 11, 12. Now if you look at here, this, it falls on 4, 8, then 12. That means we are sure that it will always fall in such a way that it is a multiple of 4. It will be a multiple of 4. So we have to check here. That means this one we have to check, we have to divide by 4. Now if you look at here, what we have, it is 20. So 20 is a multiple of 4, so it will be here. 90 into 20 means it will be here. Then we have plus 45. If it is plus 45, we have to go here, so it will fall on this quadrant. That means it will be ASTC means all positive, so here 10 will be positive, so plus 10 positive, plus 10 45 degree, and we know will not write positive, so 10 45 we know it is 1, so answer will be this one. Another example, if we take, say, let me take an example from the book. Say you are taking tan of 620. Tan of 620 is there. Instead of 10 I will take say sine of 620. Sine of 620. Now what you have to do, at first you have to divide it by 90. So 90 how many times we can give? 9, see 962, we have to see 620. So 9 7 is 63, 9 6 are 54, so 540 plus 60. So what we can write, how many times we can give? 90 into how many times we can give? 9 6 are 54 plus 60, so it is 9 6 are 54 plus 60 is 620. Okay, now what it will be? Now it is, if you look at here, it is even multiple, so obviously sine will remain same and this 60 degree will remain same. Okay, this 60 will remain same, so sine 60. Okay, now we'll go for the sign convention. We'll see the quadrant. This is the multiple of 4. Okay, now we know this 6 is not a multiple of 4, so we'll take nearer to it. So we divide 6 by 4, we'll have 4 at least, then this is 5 and 6, so 19 to 4 here, then 5 and then 6, then we have plus 60. That means it will fall in this quadrant, the third quadrant, and we know the third quadrant is positive only for 10, so that means the answer will be negative here. So minus sine 60, and we know minus sine 60 is minus root 3 by 2. This way we can find different values of different trigonometric ratios. Okay, next we will learn how to write geometry, how to go for the geometrical interpretation of different angles. Okay, thank you for watching this video.